Come on, everyone. Strap on your polynomial tool belt. We've got some polynomials to solve. Do you realize that there are quite a few tools available when it comes to solving a polynomial? And some of them are already right here in our tool belt. What's that most fundamental tool? The most fundamental idea when it comes to solving a polynomial? You know, plugging a number in to see if it equals 0. So what tool would you think of as the most fundamental? What's that? That's right, a hammer. Plug it in, see if it's equal to 0. What other tools can we add to our polynomial tool belt? How about that idea of factoring? Now, when I think of factoring, I think of like cutting up a polynomial. Cutting up a polynomial with a saw. Yeah, we'll put a saw in our polynomial tool belt. Or maybe I'll just sit it right here on the workbench. Some other tools that are already in the tool belt? What about that idea of graphing something? Graphing to see if it's going to be a root. Now, when it comes to graphing, we need something with power. Something with power? That's right, a power drill. We'll add that to our polynomial tool belt too. What about solving this polynomial? It's going to be pretty tricky to use the hammer on this if I don't have any solutions to plug in the first place. And you're going to have a hard time factoring this because, well, there's not two numbers that multiply to be 10 and add to be -8. And I don't have my graphing calculator with me, so there's no way that I'm going to be able to graph this and find the roots. So what are we going to do? Well, we need a specialized tool, one that is especially used when you have a polynomial of the degree x squared. And I know just the tool that will work. It's called completing the square. That's right, we can complete the square of this polynomial. Now, when it comes to woodworking, there's a specialized tool that's used for hanging crown molding. It's called a coping saw. Crown molding is that molding that sits in kind of the corner of your wall and ceiling, sometimes in a dining room or in a special room. And when you want to get the joints put together, that is at the corners of the wall, you have to actually cope back on your crown molding. That way it fits together nicely in the corner. If you don't have a coping saw, you're going to need a lot of caulk. And maybe if you fill it with enough caulk and enough paint, you can sort of hide that joint. But when you use a coping saw correctly, when you use completing the square correctly, we'll be able to solve this polynomial for its roots. Now, every polynomial is equal to 0. But when we use the process of completing the square, we also have to realize that we're going to make space for a new perfect number. And that space actually ends up pushing the number 10 kind of over out of the way. So what is this number we're going to add in? What is this perfect number? Well, I always like to tell kids that it's simply going to be half of your x number. So half of -8, which is -4. So it's going to be half that number squared. That means -4 squared, which is equal to 16, is the number that I'm going to add into this equation. Now here's the thing, if I'm going to add 16 in this equation, I got to also take away 16. So there was actually space here on purpose for us to also subtract 16, because what I giveth, I must taketh away. So what just happened here? Well, essentially we added and subtracted the number 16. Why? Well, because that's the perfect squared number that allows me to write this now as x minus 4, the quantity, squared. So you see the number 16 actually completes this square, which again allows me to write this as x minus 4 squared. Now, make sure you realize that we get a new number sort of happening over here. That's the number 10 minus 16. So it looks like I can write this as x minus 4 squared minus 6 now is equal to 0. We see when you write that polynomial in this perfect squared form, it's pretty easy to solve, right? when it comes to solving this, I'm going to be doing things like adding 6 to both sides. I'm going to be doing things like taking the square root of both sides. And of course, as soon as I take the square root, I end up with plus or minus the square root of 6. But that also frees me up to be able to do one last step, which is to add 4 to both sides. And all of a sudden, I just solved this thing for x, which is equal to 4 plus or minus the square root of 6. And that was all brought to you by that perfect number, that number 16. Okay? It's pretty specialized technique. And keep in mind that it only works for a polynomial of the x squared form. But boy, it's pretty slick as long as we complete the square. What about this polynomial? It certainly has some larger numbers, but the real problem is that it has a coefficient other than 1. You see, you can't do the process of completing the square when you have a coefficient. So, what about this polynomial? It looks like that it has some larger numbers. Indeed, it does, but the real problem is that it has a coefficient other than 1. You see, you can't complete the square when there's a coefficient in front of your x squared. But if you factor off that coefficient, well, we will be able to complete the square. The other thing is that we're not going to factor the number 2 off of 65. Now, that's not because 65 is an odd number, but it's because that number doesn't have to be part of this process of completing the square. What are we talking about, this process of completing the square? Well, remember, you want to think about half of the x term. Now, half of the x term is negative 5 squared. So negative 5 squared is 25. Now, we're going to put the number 25 in the parentheses, but I have a question for you. What number did I actually add into this polynomial? What do you mean, what number did I actually add? It looks like I added 25. Well, I mean, what value did you actually add? You see, you didn't actually add 25, but you added 2 times 25. That's right, you added 50. Now, if you giveth 50, if you add 50, you must taketh away. You must take away 50. So I end up with my polynomial now being able to be rewritten as 2, and then here's the perfect square. That is x minus 5. Remember, where did that 5 come from? It's just the half number. So I can write it as x minus 5 squared. And I'm kind of getting a new number generated over here, okay, and the number 15. So I end up now being able to solve this equation kind of like, with inverse operations. I'm going to subtract 15, I'm going to divide by 2. I think we can kind of do that in 2 steps. Now, negative 15 divided by 2, that's not necessarily real pretty, but that's what we get. So that when we take the square root of both sides, we're actually going to be taking the square root of a negative number. Now remember, the square root of a negative number opens up that imaginary can of worms. So let's kind of get this cleaned up. You end up with plus or minus. You always get plus or minus as soon as you take the square root. But the negative is going to come out as the letter I. I still have 15, or that is the square root of 15 over 2. Okay, and once you add 5 to both sides, you're able to create this final answer that looks like 5 plus or minus I, the square root of 15 over 2. Now, we could do something with the square root of 15 over 2. We could kind of like rationalize it. I'm not too concerned about that at the moment. I just want you to realize that we ended up with what's called a conjugate. A conjugate is that idea of like a number plus or minus a value. So that often happens when you have a completing the square answer. And of course, it worked here even with the imaginary number. What if we wanted to solve any quadratic equation? I mean, a quadratic equation where there will always be an ax squared, a bx, and a c. Could we complete the square for any quadratic equation? Well, the answer is yes, but more the question is how. How do you complete the square for any quadratic equation? Okay, I would say very, very carefully. You're going to have to be very careful with your coping saw here so that we can end up with some pretty nice joints. Now what I'm going to do is walk you through a little bit of sort of the theory of solving ax squared plus bx plus c. We're going to complete the square, and we're going to very carefully go through each step, starting with factoring off your coefficient. Now, when you factor off your coefficient, you also have to factor it off of bx. Somebody might say, well, how do I do that? I don't even have a b, I don't even have an a on my bx to begin with. But instead, what you want to think is, okay, so if I take off an a, what value would need to be sitting there so that I could still remain as a bx? Okay, it turns out that it would be b over a. Let me explain. I want you to kind of see how we're organizing the rest of this problem. You might notice that the c was not part of that. Listen, factoring is just doing the distributive property backwards. So if I would do the distributive property, it looks like that those a's would cancel. That would leave me with just bx, which of course is what we started with. Ready for the next step? You want to think about half of b over a. Now stop right there. Half of b over a is b over 2a. All right, I can think of that. So half of b over a is 2a squared. Squared. Okay, yeah, I can actually square both of those terms, or I should say the numerator and denominator. So that's going to leave me with b squared. And then let's write it as a 4a squared, because of course we have to square the entire denominator. Now, what did I really add into this problem? Did I really add b squared over 4a squared? No, I have to take into account that that a would come back in. Now, if that a comes back in, that's going to kind of simplify a little bit with the a squared in the denominator. So it turns out that I need to actually giveth, or I should say we giveth b squared over 4a. So I'm going to have to take away b squared over 4a. Okay, careful a little bit there with that a value. All right, looking quite a bit complicated here, but never fear, it actually gets a little simpler because we can always write this as x something squared. And the good news is that the something squared is just the half term. What do I mean the half term? Well, it was b over 2a. Remember, we were just thinking about half of that b over a squared. And then over here with my c value, that is my c minus 4b squared over 4a, I can actually do a little bit of sort of combining there. Now, to combine that, I'm going to need a common denominator. So I'm going to go ahead and do that in this step so we can basically save a step. Again, for me to subtract c minus b squared over 4a, I need a common denominator. And that's going to end up giving me something of the form of 4ac minus b squared. Of course, that's just the numerators, all over 4a. Remember, that's your common denominator. What are we doing? We're completing the square for any quadratic equation. Okay, now it's time to solve this. Okay, you're solving it for x. I know we have lots of strange numbers, but this big giant number right here, it needs to scoot over to the other side. It always gets added or subtracted to the other side. In this case, I can kind of think about like subtracting it to the other side. So let's show that. Okay, now if I move that fraction over to the other side, if I subtract it, it's basically going to change the signs. It's going to change the order of my numerator. So my numerator now is going to be b squared minus 4ac all over 4a. Starting to look like something here, all these a's, b's, and c's. So again, I subtracted that to the other side. It basically kind of changes the order of my numerator, or you might say changes the signs of the numerator. Let's keep going. I think I have to divide both sides by a. Now, when you divide both sides by a, you don't need like another division bar. Okay, you already have a division bar, so you can just divide by a in the existing denominator. So that's going to give me x plus or minus 2a, the quantity squared, over again b squared minus 4ac over 4a squared. What's next? That's right, you're going to take the square root of both sides. Now, when you take the square root of both sides, you're going to end up with a plus or minus. The square root of the numerator, b squared minus 4ac. I feel like I've heard that before. Plus or minus the square root of b squared minus 4ac. All right, and then the denominator, okay, that is the square root of the denominator. And we can actually do the square root of the denominator. You know, you can square root 4 and get 2. You can square root a squared and get a. Okay, we're getting close. Close to what? Okay, well, let's subtract b over 2a from both sides. Okay, now take a look at what's happening here. We're subtracting b over 2a. We already have a common denominator. So I can basically put those fractions together. Okay, we're talking about the numerator, negative b, can now be beside the plus or minus the square root of b squared minus 4ac all over 2a. Do you see what I see? We just created the quadratic formula. Oh my gosh, somebody needs to sound the alarm. We just created the quadratic formula. Wow. If you complete the square for any quadratic equation, you get
x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
the quadratic formula. Okay, it's actually the result of completing the square for any quadratic equation. Now, the quadratic formula, this is a new tool for our tool belt. What kind of tool can be used on any type of, well, any type of piece of wood? We need something that works like all the time. Okay, it's a sawzall. That's right, a sawzall. It literally solves all. And just like the quadratic formula, it will be able to work on any quadratic equation. Now, I always like to tell students, you need to be able to teach your kids the quadratic formula. Okay, like this fellow here. Hey, homework helpline, I need to have you explain the quadratic equation and roughly the amount of time it takes to get a cup of coffee. Okay, I'm being serious here. You need to be able to teach your kids the quadratic formula. And if you don't want to teach it to them, then don't have kids. Well, what I'm really saying is you need to know the quadratic formula. This is a staple when it comes to solving polynomial equations of the degree x squared. So can I use the quadratic formula on this polynomial? X cubed plus 12x squared plus 76x? Well, sort of, once I make it a quadratic equation. Remember, the term quadratic just means that you have an x squared. So if you notice this polynomial, well, it has kind of an extra x, of course, that you can factor out, you know, like GCF factoring. So once I factor out that x, then I am left with a quadratic equation. And of course, I can use the quadratic formula. Okay, now, if we use the quadratic formula, I should say when we use the quadratic formula on this, okay, practice this with me because it's going to be the only one that we do. We're going to do the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now b squared minus 4ac, you might remember that that's called the discriminant, and that's kind of like the heart of this problem. You want to very carefully calculate that. Some people will type that in their calculator. Some of you will kind of chunk it out a little bit. No matter how you do it, you want to make sure you end up with the square root of negative 160. Now, that's all over 2 times 1, not 2a, but 2 times 1. So, of course, it's going to just be all over 2. Negative 12 plus or minus square root of negative 160. Oh, wait, the square root of a negative number. Okay, yeah, we can do that. You can bring the negative out as the letter I. What else happens here? We get the square root of 160. If you think about the square root of 160, you can kind of split that up into 16 times 10. Of course, the number 16 is that perfect number that's also going to be able to come out. So yeah, we're simplifying the square root. We're going to write this as 4, and then we still have the square root of 10 sort of left over. Okay, so when it comes to simplifying the quadratic formula in a case like this, you can and you should do the Hart method, where you divide all of these by 2. Notice that I did not divide 10 by 2, but I'm going to end up with negative 6 plus or minus I 2 root 10. Now, those are the solutions that came from my quadratic part of my equation, but don't forget this x that you pulled out. It also has a solution, just a nice little x equals 0. So if you count with me, you should see that we have 3 solutions. We have 0, and we have negative 6 plus or minus. The plus or minus gives us 2 more solutions, 2 root 10. Of course, that's a total of 3 solutions, and that satisfies that fundamental theorem from a few days ago. Well, how's your tool belt? It's getting a little heavier, right? Okay, well, we added to it completing the square, which of course created the quadratic formula. I want you guys to practice using both those tools very carefully as we continue our journey on solving polynomial equations. Shh, I've got a little secret for you, but don't tell anyone. For bonus on the next test, you're going to have the opportunity to prove the quadratic formula. That's right, showing each step as how we completed the square for ax squared plus bx plus c. If you're able to show each of those steps carefully, creating the quadratic formula, it's going to earn you a little bit of bonus. Okay, but don't tell, because I'm not going to remind you. That's your bonus question on the next test.